then is coming from topic 2, which is all about atomic structure. And this is real fundamentals when it comes to understanding chemistry, because of course we're looking at the periodic table here. My key to this question then is to remember that mass number is contributed to by the number of protons and neutrons in an element. So the protons and neutrons are the heaviest subatomic particles within an atom. And then the electrons are considered to be so tiny that we basically ignore the mass that the electrons have. So therefore, when you consider the mass of an element, which is the more massive or larger number associated with all the elements, so I always remember mass number is the more massive number associated with an element, and it's also the number which is quoted to 2 decimal places on an IB periodic table. So the mass number is, as I say, made up of the number of protons and neutrons in an atom. And then by taking the atomic number and looking at that, you can figure out what the number of protons are. Now, the number of protons have to equal the number of electrons if it's neutral. So if you're talking about a neutral atom, then the number of protons will equal the number of electrons. The positive charges equal the negative charges. If you have something which is ionic or has a charge associated with it, for example, if it's negative here in this nitride ion, then it must have an excess of the negatively charged electrons. Again, also in this oxide ion here, again, an excess of the negatively charged electrons. This carbon atom down here is one version or isotope of carbon. Of course, you can have carbon 12, you can also have carbon 13 and carbon 14, but in this case, they've given you carbon 11, but it's neutral. So you can say that you have the same number of protons and electrons just from looking at it. But in this question, they're trying to see which 3 of the combinations that you've been given will all have a situation where you have more electrons than you have neutrons. So we basically have to see, can we work out the number of protons, neutrons, and electrons in each one of these species. So for the first one here, the nitride ion, so nitride, NIT or IDE. So the IDE suffix or ending goes for any negatively charged version of an element which doesn't have oxygen associated with it. So nitride, this one here would be called oxide. So there are 2 ions that you need to be familiar with. But anyway, let's work out the number of protons, neutrons, and electrons. So for the first one, we have in this case, if it's 14, well, 14.0, we can confirm there that must be the mass number. And I'll just write down the atomic number of each of these elements that we can take from the periodic table, which of course is at the beginning of paper 1. So the atomic number of nitrogen is 7, the atomic number of oxygen is 8, and the atomic number of carbon is 6. Now, our little meme up here is just relating to quite an important point, actually, which sometimes comes up on multiple choice questions. The IB talk about the fact that originally on the periodic table, the elements were actually arranged by mass, atomic mass. And as you can see here, there's a bit of an anomaly if you follow that trend. So on the periodic table, if we go as far as astatine here with a mass number of 74, then it's increasing the whole way. And then it gets as far as tellurium at 127.6. But then the mass drops again for iodine. So this pattern actually broke down. So in the end, chemists decided to arrange the elements by atomic number instead, starting with element number 1, which of course is hydrogen, moving on to helium with atomic number 2, and so on. So you should be able to track from number 1 all the way down to 100 or so on any periodic table and see that's how the elements ended up being arranged. Okay, so back to our nitride ion. So we have a mass number 14, which tells us that we have 7 neutrons and 7 protons. Now, you can't change the proton number or the atomic number because, of course, then you've changed the identity of the element. If we were to say we had 8 protons, well, then, of course, we're talking about an oxygen, the element oxygen in that case. So we have 7 neutrons and 7 protons. What can change is the neutron number can change in isotopes, or alternatively, the number of electrons can change when you change an atom to an ion. So in the nitride ion, if it was neutral, you would also have 7 electrons, but because we have an extra negative 3 charge, we have an extra 3 electrons, so we have 10 electrons. So this first one does meet the criterion where the question asked you to identify if the species had more electrons than neutrons. So the first one, the nitride ion, has 10 electrons and only 7 neutrons. The second example with oxide, we can be a bit faster now that we've explained what we're doing. So with a mass number of 16 or a larger number of 16, that tells us that you have 8 neutrons plus 8 protons. In this case, though, again, it's an ion. So instead of having 8 electrons, which the neutral oxygen atom would have, it has 2 extra, so it has 10 electrons. So again, this situation has more electrons than neutrons, so that meets the criterion to be correct for the question. And in the last example, although it's neutral, it has an odd number for its mass number. So therefore, in this case, the 6 tells us we have 6 protons. And therefore, if you subtract the 6 from the 11, that will tell you that you have 5 neutrons. And for this to be neutral, you must have 6 electrons. So although it's neutral, you can see that you still have one more electron than neutron. So that's why the answer to this particular question would have been the letter C.